Hello everyone. So today we are going to do superposition theorem. So it is a part of DC network theorem chapter of your syllabus. So first we have to know where we can use this superposition theorem, how we can use this superposition theorem, and what is the procedure to solve this superposition theorem. So as we know, so first we are coming to the definition of the statement of the superposition theorem. So before coming to the statement of the superposition theorem, initially we have to understand that why and where we can use the superposition theorem. So superposition theorem is basically the application of the Ohm's law, extended Ohm's law. That means in Ohm's law what we do. So we know V is equal to IR. We all know that. But if the circuit is a large one, if the circuit contains two or more than two sources, then we can use the superposition theorem. So first of all, before coming to the statement of the superposition theorem, first we have to know what are the conditions when we can apply the superposition theorem. So three things are there. One should be the circuit should be linear, the circuit should be bilateral, and the circuit must contain two or more than two sources. So a very important point is there. So a circuit which has only one source, there we cannot apply the superposition theorem. A circuit which contains minimum two numbers of source, maybe voltage, maybe current source, we can apply superposition theorem over there. So now coming to the statement of the theorem. So as we can see over there, the theorem states that superposition theorem states that in any linear active bilateral network having more than one sources, the response across any element is the sum of the response obtained from each source considered separately, and other sources are replaced by their internal resistance. The superposition theorem is used to solve the network where two or more than two sources are present and connected. So already we have discussed that for applying superposition theorem, we need two sources. The circuit should be linear, the circuit should be bilateral. Now the point is how we can solve the theorem. So as per this theorem is concerned, that the superposition theorem, if a circuit contains two or more than two sources, maybe voltage, maybe current, so there what we will do, we are going to consider when we are solving actually, we are going to consider a single source at a time, and we will remove other sources, and using that source we will going to find out so what is the branch currents, what is the branch voltages, and then other sources we have to consider individually, and for that source only what is the current and voltage to the each branch. So like this way we will calculate for the each source, and at the end we will sum up the branch currents and branch voltage, and we can find out that when all the sources are acting together, so at that time what is the branch voltage and current, that is actually same to the when we are considering that a single source at a time. Okay, that is actually depicted in this statement. Okay, now we have to go further. So for your understanding level, so what I have done, I have considered a circuit which contain two voltage source and three resistor. So when we are going to solve, so what we will do, we will at a time we will consider, say there are two sources V1 and V2. So once we will consider this V1, we will remove this V2, and we will find out through R1, R2 and R3 how much current is flowing, and across that resistances how much voltage is appearing. Like that way we will consider this V2, and this, due to that V2 how much current and voltage is there in each branch, that we can find out, and at the end we will sum up. And when we will sum up, we can find out that when both sources are present, as we can see in the picture, so at that time whatever is the current and voltage through the branch, that is actually same when we are considering single source. Okay, so now one thing we should remember over there, that is there are two kind of source in basic um, syllabus. We have mainly two kind of source: independent voltage source, independent current source. So mainly we can say that there is a voltage source, there is a current source. Now for our simplicity, we are considering that voltage source and current source are ideal one. So if we are considering ideal voltage source, then we can say that, so when ideal voltage source has zero internal resistance, and an ideal current source has infinite amount of internal resistance. So, and as per rule, what in the coming to this particular diagram. So in this particular diagram, what we can see, there are two sources, v1, v2. Say we are considering this v1 and we are removing this v2. So when we are removing, so as per the rule, we have to leave its internal resistance over here, and as we have considered this is an independent voltage source, so its internal resistance is zero. So if its internal resistance is zero, then when we are removing this one, so what we have to do, we have to leave its internal resistance zero over here. So what is that then? What will be the resistance value? Zero. Zero means we can make the terminal short, and the short path will give us the zero resistance, like this way. If we consider instead of v2 there is a current source i2, say. Now if we want to remove current source, what we have to do, we have to leave its internal resistance over here. And what is the internal resistance of this current source? It has infinite amount of internal resistance. So what we have to do when we have to remove the current source, we have to make this terminal open and leave it, because our open terminal always offer us infinite amount of resistance. Okay, so clear. So two things to remember for this particular theorem, that when we are removing voltage source, we are, if it hasn't any internal resistance, then we will make that terminal short, and when we are removing current source, at that time we have to make the terminal open. Okay, so remember these 2 points. Now coming to the uses. So what are the use of the superposition theorem? The superposition theorem, as I have already told, that the superposition theorem extends the use of the Ohm's law to circulate to the circuits with multiple sources. Okay, next, number two, the superposition theorem is very helpful in determining the voltage across an element or current through a branch when the circuit contains multiple number of voltage source. Okay, already we have discussed. So coming to the next point, terms to know. What are the terms to know? So basically in the statement we have seen that linear, bilateral, those terms, active, those terms we have learned. So what is the meaning? Already we have discussed in the previous classes, but for now just we are remembering those points. So what is linear? Linear means, say I have considered a resistance symbol below there. So original view of the register and the symbolic view of the register, both are kept over there. Now say in the symbol of the register, so there are two ends, two terminals, correct? So one is, we can say for our simplicity we are considering there is a left hand arm and there is a right hand arm, as you can see in the picture. So if we connect source in the left hand arm, then what we can say, the current will flow from left side to right side. And if we connect that mm, source over there in the right hand side, the current will flow from right side to left side. So both the direction current can flow. So this is one parameter. This is basically known as the bilateral edges. Number point number two. So point number two, here I have discussed this one. What is the bilateral? That means both the direction current can flow. So element which has this property can be used for solving the superposition theorem. Now the linear. The linear means, in one line we can say that the element which follows the straight line equation. So what is the straight line equation? Y is equal to mx plus c. That means the graph plotted between v and I, if we consider voltage in the x-axis and current in the y-axis, the characteristics will be linear. That means when voltage is increasing, current is increasing. When voltage is decreasing, current is decreasing. So in that case, we can use this superposition theorem, and that property is known as the linear property, and the element which has this property is known as linear element. Okay, so linear means vi characteristics will be linear, it will follow the straight line equation. Bilateral means both the direction current can flow, as we have mentioned. Okay, mm, passive components may be used. That means resistors. Passive means what? Which doesn't has any source of PMF. So that kind of element we can use for solving the superposition theorem. Okay. Active components may not be used. So if we are using any active components, it has its own effect in the circuit. So directly we cannot find out the individual branch current, individual branch voltage like this. So these are the points to remember. This is a very important thing, because after this theorem we have Thevenin's Norton different theorem, and for all those theorems we have to again and again and again we have to remember those terms, linear, bilateral, those terms, very important. So we have to remember those things. And now, just for your simplicity, before going to the procedure of the solution, I have kept over here the pictorial representation how we can solve a superposition theorem. So there are three circuits as we can see: circuit diagram A, circuit diagram B, and circuit diagram C. So as we can see in the circuit diagram that um, in this circuit diagram A we have two sources, E1 and E2. Okay, so and just carefully view that E1 has its internal resistance, that is R1, and E2 doesn't has any internal resistance. And there are three circuit resistances there: R1, R2, and R3, and through that I1, I2, and I3 current is flowing. So we have made some assumption, the current directions. Okay, now what we are going to do in the circuit diagram B, what we have done, we have considered E1 present in the circuit and we have removed E2. See what we have done with the terminal. See, as this E2 doesn't has any internal resistance, so when we are removing, so what we have done, we have made the terminal short. And in reverse case, when we are considering E2 and when we are removing this E1, E1 has some internal resistance. So we have to lift the internal resistance over here. So that's why you can see that the E2 we are considering, and the internal resistance of E1 is there in the circuit diagram. And for that source we will again consider how much current and voltage is there in resistor R1, R2, and R3. So like this way we are going to solve. So we are going to consider each source at a time, and we will consider we will solve for that source, with particular source, what is the current and voltage through the each branch. Okay, so now explanation of superposition theorem. So as we have discussed, so first I am considering a circuit. So what is the circuit? There is a two source, V1 and V2, both are showing here. There is no internal resistance, and three circuit resistor are there, R1, R2, and R3. So for the very first case we are considering that V1 is present in the circuit, but this V2 is absent. As this V2 doesn't has any internal resistance, so what we have done, we have short that terminal, see, as you can see over there, and the current is flowing from this side to that side. As this potential is mentioned over there, is a high potential, and lower there's a lower potential. So now see, so how we are going to solve this circuit? So what is our aim? Our aim is to find out how much current is flowing through this R2, how much current flowing through this R3, and how much current is flowing through this R1. Correct? So, and if we can find out the current through this R1, R2, and R3, then what we can do? We can we can find out the voltage also, because current into voltage, Ohm's law, that will give us the voltage across each branch. So first of all we have to find out the currents, branch currents. Now if we just carefully view, so from where the current is producing, the current is producing from this source only, because we have a one source in the circuit. So we can we say that this I1 bar, as I have mentioned over here, this I1 bar is a source current, and coming to the node, it is marked over here that current is dividing into two sections. One is passing through the R2 and some current is passing through the R3 as per the resistance value. If resistance value is high, less current will flow. If the resistance value is low, the higher current will flow that path. Correct? We know this concept. So we can say that the from V1 the current is flowing through R1 first, then coming to the node, it is dividing as per the resistance value. Okay, so if we want to find out the branch current, first of all we have to find out how much the source current is producing. Then applying the current division rule, we can directly find out how much current is flowing through this R2 and through this R3. So first find out the source current. That means source current means the current producing from the source, that is I1 bar. So how to find out? So to find out that, what we have to do, first of all we have to find out the equivalent resistance of the circuit. So as the circuit is concerned over here, so we can say that this R2 and R3 in parallel, and with that this R1 in series. So if we come to the below section, so as we can see here, R2 R3 in parallel, that's why this equation R2 R3 by R2 plus R3, in there with that this R1, the source resistor connected, the resistor connected with the source is connected in series with this two parallel combination. So that's why in series. Now applying the Ohm's law, V by this whole equivalent resistance will give us the source current. This is I1 bar. So that thing we have done over here, this I1 bar is equal to V1 by the combination of this parallel and series resistance. Okay, now what I have done over here, just applied the current division rule. So current division rule, the first we have find out I2 bar, that is equal to the main current or the source current I1 bar into, see here we are we want to find out that current passing through this I2 bar. I2 bar means here in the picture, so I2 bar means this current. Now if we want to find out this current, so again if we come to the, so the current passing through this the current passing through the resistor is R2, but when we are writing the equation, see what we have written, R3 over here by the summation of two parallel resistances, see R2 plus R3. Okay, so this is the rule. So that means if we want to find out the branch current, I2 bar is equal to the total incoming current, that is I1 bar, into opposite branch resistance by the summation of total parallel resistance. So we can say that when we are finding out this I2 bar, so at that time we write down what will be our equation. Our equation will be the total incoming current I1 bar into its parallel resistance is this R3, so R3 will be there, and by summation of R2 by R2 plus R3, as you can see over here. So like this way we can find out I3 also. So for I3 we can write down the equation I3 bar is equal to I1 bar into, for I3 the opposite branch resistance will be R2, so here we will write down R2 by R2 plus R3, or as we know I1 and I2, so we can say that this current minus this current will give us this current. Simple. So like this way I have done over here, so we can do that. Now the same procedure we can repeat when we are considering this V2. So when we are considering V2, so as we can say that this I2 double bar, the current is the source current, because here now the source is V2, no longer existence of V1. So now this V1 current, so this V1 current, this I2 double bar current will pass through this R2, and coming to this node it is dividing into two sections as per the resistance value between R1 and R3, and the currents are I1 double bar and I3 double bar. So here we can say that the equivalent resistance for this particular circuit, we can say this R2 and R3 in parallel with that R2 in series, correct? So previous method, as we have mentioned, so here first we have to find out the main current, then we have to find out the branch current. So branch current, how we can find out? Applying the current division rule. So same thing we will repeat over here. So first we are finding out this I2 double bar, see this is the main current, then we are finding out the I1 bar, this is the branch current using the current division rule, as we have discussed already we have discussed this one. So we can find out that, and after that just I2 double bar minus I1 double bar, same thing what we have done in the previous step, same thing we have to repeat, considering V2 as a source, and due to that the current direction will change, and as per that resistance, equivalent resistance we have to calculate, then we have to find out the main current, then we have to find out the branch current. So like this way we have to again and again and again we have to calculate. So in the circuit if we have three source, so we have to consider each source at a time, and for each source we have to do the same thing. Okay, so after doing that, okay, now we have to check what is the total current. Okay, so what we have done, see here, as we can see that I3 is equal to I3 bar plus I3 double bar, I2 is equal to I2 bar minus I2 double bar, I1 is equal to I1 bar minus I1 double bar. But the question may appear over here, that is, there is a plus, there is a minus, there is a minus. So we, when you are going to solve, so what you are going to put over there, plus or minus? So basically there is no rule such that you have to put plus or minus. So it is basically a logic. What is the logic? If we know the logic, if we can understand the logic, we know very good what we have to write, plus or minus over there. See, coming back to our diagram where both sources are present. See, in when we are considering both sources, no, not this one, when both sources are present, so that time we can think that, see, the current may flow like this from V1, the current from V2 can flow like this, and it can go like this direction, or this current can flow this direction, or both current flow this direction, because it doesn't know, because V1, V2, R1, R2, R3 values are not known to us, so it doesn't know in which direction this current is going to be flow. Now, when we are considering single source, now at that time we know in which direction actually the current is going to flow, because it depends upon higher potential to lower potential, correct? So as it is mentioned over there, this is the higher potential, this is the lower potential. So very simply we can say that the current will flow as the direction are mentioned over there. Now if we just check, so the direction here, the if we just remember, for remembering purpose, we are considering that this I1 bar, this current is flowing from left hand side to right hand side. This I2 bar current is also flowing from left hand side to right hand side, and this I3 current is flowing upward to downward, correct? So just remember for 1 minute. Now coming to the circuit number 2. So here we are considering that V2 is the source, and now just see the what is the current direction. This I2 double bar current direction is right to left, I1 bar current direction is also from right to left, and the I3 double bar current direction is upward to downward. Now just compare the direction of the when only V1 is present and when only V2 is present. So we can find out that in both case I3 direction is downward when V1 is present. At that time also I3 bar direction is downward when V2 is present. At that time also this I3 double bar direction is downward. But in case of this I1 double bar and I2 double bar, just check yourself, you can find out that both direction is opposite. So opposite means there should be a minus, so which will be minus and which will be plus. So it, I think when you are going to solve, just check this one, that from the larger amount you just subtract the smaller amount, that will make you a easy solution. Okay, so higher value of current or higher value of voltage you subtract from the lower value of voltage and lower value of current. Okay, so like this way you can do, and in that procedure it is mentioned, see, as the I2 bar and I2 double bar direction is opposite, and I1 bar and I1 double bar direction is opposite, that's why there is a minus between them. But as I3 bar and I3 double bar both has the same direction, that's why there is a plus. Okay, so like this way we can solve the superposition theorem. Now coming to the last part, okay, limitations of superposition theorem. So at the end we can say that the superposition drawback of the superposition theorem is, um, we cannot find out the power. Why we cannot find out the power? Because in the initial state of this theorem we have already discussed the theorem can be applied in a linear circuit, but power itself is not a linear component. Okay, so because power is equal to basically we know P is equal to V into I, so this is in the square term. Okay, so it is no longer linear. Okay, this is a multiplication of voltage and current. That's why we cannot use the superposition theorem to find out any power kind of thing. Okay, so next is, okay, if the choice of the load is variable or the load resistance changes frequently, then it is required to perform every source contribution of the each current or voltage and their sum for every change in load resistance. So it is complex for you, because when we are solving using a single source, so at that time, say we are considering a variable source, say R1 is a variable, not source, sorry, it is a variable resistance. So if we are considering a variable resistance, now when we are considering V1, at that time its resistance is 30, and when we are considering V2, at that time its resistance is changing, suppose say 33. So if the resistance value is changing, so we cannot find out the accurate answer. The resistance must be fixed over there. So if we are considering a circuit where frequently resistance is changing, so there it is very hard, very complex to apply this superposition theorem. Okay, so like this, two more limitations are there. Mainly those are the main limitations of superposition theorem. Okay, thank you.